I'm Songwei and I'm back with another Java lesson. Today we're going to be looking at static, inheritance, and constructors. So first, let's talk about static. We're going to be looking at static methods, static variables, the final variables, and getters and setters. So what is static? Well, static methods and variables means that they belong to a class and you don't need an object to use it. So normally if you have something in a class, then you have to create an object before you actually use that variable or method, but if it's static, then you don't have to make the object to use these methods. So for example, the methods in math are static, like math.max, you would call a math with a capital M max, and you don't actually have to create like a math object to use the max or min or any other function in math. And another way we can know that max is a static method is because math is capitalized, which is normally how class names are written in Java. They're written with a capital letter. So let's take a look at an example class that I wrote. So this class is called dice, and it has a public static final variable called sides. Final means that once you've created that variable, you can't change the value anywhere. So once we have like sides for one of the die, you can't change the variable, you can't like change the value of sides anywhere else. So, and normally final variables are also written in all capital letters. Then we also have a variable, just a normal variable called rolled, and this is the constructor, which I'll explain a little bit later on. But basically a constructor is kind of just like setting up the object, and it's like the default conditions or like the default things that some parts of the class or object are set as when you first create it. So this is called a getter, and we know that it's a getter because of the get here. You can also have a setter. So a setter would be a public void because it doesn't actually return anything. Set rolled, and you would take whatever thing you want to set it to, and you would set the variable in your class to whatever the parameter is. And that's a setter. And we know that this is a setter because of the set in front of it. So this is also a getter, but it has static in front of it, which means you don't have to create an object to use this method, and this will return sides. What happens if we, let's say, add like get rolled and get sides? Well, then this method actually doesn't work because one of the methods is static and one of the methods isn't static, which means you can't call the get all method in the same situation. Now let's look at how this would work if we test it out. So if we create an object called dice and we call it dice, dice.getRolled works since it isn't static and we're actually creating an object before calling the getRolled method. But if we do capital D, which is the name of the class.getRolled, that actually doesn't work because getRolled isn't static. If we do capital D dice.getSides, however, that does work since getSides is a static method and dice is the class. Now let's look at inheritance. So here we're going to be talking about superclasses and subclasses. So the main concept of inheritance is kind of like what you would think with parents and children. So the classes are sometimes also called like parent classes and child classes. And basically, with this example, if we have a parent class called animal, which is kind of like the head of all of the other classes, then you can have a subclass called dog and then a subclass called cat. So for example, if the parent class animal or the superclass animal has methods like speak, eat, and move, then dog will also automatically inherit those methods. So dog will also have speak, eat, and move, and then it can change those methods to be whatever like the dog wants them to be. So for example, inside dog could have a bark method and then another bark method in the dog class separately. And the same thing for cat. So cat would have speak, eat, and move, and it would be able to adjust those methods, for example, like add a meow. And then we can have more inheritance. So if there's dog, then you can have beagle and poodle as subclasses of dog. And when you change the method, this is called overriding. So beagle could override the bark method that dog has as yip and also add another yip method onto it. And the same thing for poodle, and you can do this an infinite number of times, but you can't have a subclass inherit more than one superclass. So it's only one superclass per subclass, but one superclass or parent class can have multiple subclasses. And the way you would do this in code is, for example, if I were to create one, then you would do extends game, and this would automatically extend to whatever class you want it to inherit. Finally, let's look at constructors. So we're going to be looking at making and using constructors and this. So first off, what is a constructor? Well, a constructor is a special kind of method that is called every time an object is created. So how do we know it's a constructor? Well, the name of the constructor should be the exact same as the class name. It has the same capitalization, same spelling, and there's no return type. So if we go back to our dice class, then we'll see that this is a constructor. So in this case, we're supplying dice with an actual constructor, but if you don't give your class as a constructor, Java gives it a default constructor with no parameters and no actual information. So this is the default constructor that Java gives every single class. You don't actually have to type it in, but if you do want to make your own constructor, then you would do like public, the name of the class, and you can set whatever parameters you want. So in this case, we're getting a rolled, which would be like the number that's rolled on the dice, and then we'll set that equal to the variable in the class. So this keyword is used for the variables in the class. So you see how we have the same name here and the same name here. These are different variables. They're not the same thing. The scope of this variable is just inside this constructor method, but the scope of this variable is for the entire class, which means that it can be used throughout the entire class. So that this keyword goes to the variable that's in the entire class and not this variable here. If you really want to make it clear, you can just use different names for the variables, but this keyword is also a very important keyword, not only for constructors, but also for like calling different methods and just using it when coding in general. It also makes code a lot more readable since it's easier to follow the kinds of methods and things that are being used in the classes. So why would we actually use inheritance? Well, inheritance is a lot easier and inheritance simplifies a lot of things. For example, if you want to make some classes that have similar methods to each other, then you don't actually have to type the same methods over and over again because you can use inheritance to have them inherit them from a superclass. Thank you for listening. See you next time.